Hey guys, excited to be here. Thanks 7X for hosting me. I'm excited to talk to you guys about the dawn of the modular blockchain era. So just a bit about me. I'm Nick White. I'm the COO of Celestia Labs. And Celestia is pioneering this new blockchain architecture that we call modular blockchains. So, okay. So just to give some context and zoom out a little bit, in our view, there's been sort of like three major sort of evolutions in blockchains. First was Bitcoin, which proved that you could actually build a decentralized application using blockchain, and then Ethereum generalized that to make blockchains more useful because it made it programmable. And then finally, we're entering a new era, which we call the modular blockchain era, which we think is going to expand both the scalability and functionality of blockchains. So, sorry, it's kind of confusing here. An analogy to understand this evolution is that Bitcoin is sort of like a calculator. It had very minimal functionality. It could only do a handful of operations. And then Ethereum came along and said, hey, we can build a blockchain that's fully programmable. So Ethereum's kind of like a computer. You can write code, write applications, and run it on top of Ethereum. So it's really flexible. It's like a computer. It's Turing complete, right? And then Celestia has come along and said, actually, we're going to generalize blockchains to make them more scalable and even more flexible, sort of like cloud computing. So I think that's one way to understand what modular blockchains are, is they're like the cloud computing platform for Web3. Sorry, this clicker is confusing. And so you might be wondering, well, what are modular blockchains? Well, you have to understand what we're coming from, which are monolithic blockchains. And a monolithic blockchain is everything from Bitcoin to Ethereum to Solana to every L1 chain that currently exists. And a monolithic chain puts all of the functions of a blockchain into one single protocol, executed by one single group of nodes. And a modular blockchain basically says, hey, we can decouple these different layers into different protocols, and then those protocols can specialize in that function, and we can recombine them to build a better sort of end app platform. And so I'll just go over some of the benefits of building modular blockchains. So the first is that for the first time, we can have a truly scalable blockchain infrastructure. So in a monolithic chain, you have a fixed block size. In a modular chain, you can increase the size of the blocks, the number of transactions you can process, with the number of nodes in the network. So this is a very, very powerful thing that means that a modular chain can scale with the number of users. And this will make a huge difference when it comes to the fees on chain. And so in a monolithic chain, when there's a finite amount of block space, but there's more users and more applications joining the network, there's more demand for that block space, and eventually you get saturated, and then fees have to go up. And this has happened again and again on chains like Ethereum. And in a modular chain, you can continue to expand the block space. So even as more applications and users come and demand more block space, you don't have to increase the fees. You just increase the supply. So fees can remain constant even as the ecosystem grows. And then another part of this is that execution is separated from the bottom layers of the stack. And what this means is that you can have way more flexibility over the kind of execution environment that you run on a modular blockchain like Celestia. So one way to understand this is imagine you have a computer, but it can only run Windows, right? Then that really limits the number of applications you can run. You can't run Mac applications or Linux applications on top of a Windows machine. And this is what monolithic blockchains do. They inherently come preloaded with a fixed operating system, also known as a virtual machine, like the EVM or the C-level VM in Solana's case. And that limits the kind of applications that people can build on them. It limits the functionality. In a modular blockchain, it's just a raw computer on which you can load and run whatever operating system you want. Hold on. Okay. And then a last piece, another advantage is that a monolithic ecosystem, you end up with these silos, these kind of like independent pools of security that have to be bootstrapped from scratch. And when they try to connect with each other, have to make trust assumptions on the counterparty chains. In a modular ecosystem, when you want to deploy a new blockchain, a new execution layer, you can plug into a pre-existing resource of security, and when you want to interoperate with other execution layers, you can have trust minimized bridging. So this is a major unlock. And so to summarize the advantages of modular blockchains, we have scalability. You can increase the block size with the number of nodes in the network. You have shared security, which allows you to quickly launch your own secure chain and bridge securely to other chains in the ecosystem. And then finally, you have sovereignty, where you have the flexibility to customize and build on the stack that you want. So these are the main benefits of a modular system. And I want to bring it full circle back to this analogy that I mentioned about modular blockchains being similar to cloud computing in the Web 2 context. So in Web 2, the way that most of the sort of like Web 2 internet runs is on the cloud, right? And the cloud has at the base data centers, and data centers are these resources, a shared resource of compute. And the developers, Web 2 developers, come to the data center and they say, hey, I need this much compute, and I want to run a custom virtual machine to service my application. I want to be able to scale it down or up as demand necessitates. And the modular stack is very much the same model in Web 3. But instead of having a data center, you have a data network like Celestia. And Celestia provides this raw resource of block space on which any developer can come and say, I want to consume some of this block space, and I want to run a custom virtual blockchain, also known as a rollup, on your chain. And I want to be able to scale it up and down, and I want to customize it for my end application. So there's a lot of parallels here, and I think that's what makes the modular stack so compelling. We've already seen the success of this type of architecture in Web 2. So I want to talk a little bit about how this stuff works under the hood. So again, we have to compare with monolithic chains. So in a monolithic chain, when you want to run a node and verify the chain, you have to download every single transaction, and then you have to verify every single transaction one by one. And the problem is that node operators have a finite amount of bandwidth to download data, and they have a finite amount of compute to verify transactions. So what that means is there's a finite amount of transactions that they can download and verify, so that creates an upper bound, like a fixed amount, maximum of block space or transactions that can be processed by the system. And that's just something that can't really be overcome. And in a modular context, there are two key innovations that change this dynamic and make it so that you can actually increase the number of transactions while still retaining the core functionality of being verifiable. So the first is that rather than having to verify every single transaction one by one, in a modular blockchain, you use what's called a rollup, which enables you to verify a batch of transactions with a single proof. So this scales the execution component of blockchains. And then, but you still need to download and verify that all the transactions were published. Well, you need to make sure that the data is available. And in Celestia, we've solved this by doing something called data availability sampling, which allows you to verify that all those transactions were published without having to download each one of them. And instead, you just download a small sample of the overall data. So let's say you have a 10 megabyte block. You only have to download about 10 kilobytes of data to verify that it was published. And that the number of samples does not increase even as the block size increases. So this is similar to, like, the underlying technology uses something called erasure coding, which is something that is used in QR codes and CD-ROMs and throughout other aspects of technology. And you'll see if you try to scan these QR codes that the QR code on the right still works, even though it's missing a lot of data. And so similarly in Celestia, when you are sampling the block, if a block producer wants to hide any data, they have to hide a huge amount of data in order to get away with that kind of attack. And so this is what powers the data availability sampling that allows us to scale block space. And I want to just note for everyone in the audience that you should not confuse data availability for data storage. They're completely different things. Data storage is sort of like storing food. It would be like, I want to can food and store it away in a warehouse so I can eat it later, right? You want to put data away and know that you can retrieve it when you need it in the future. And data availability is more like an all-you-can-eat buffet. It's trying to serve data out to as many people as possible and enable them to sample from each dish and verify that all of the food that's supposed to be in the block and in the buffet is actually there. And so it's about fresh data, it's about new data, and ensuring and verifying the chain, rather than storing data. And what's really cool about modular blockchains is that they enable an entirely new type of node that's never existed before, called a light node. So what a light node is it's a way for end users to verify blockchains on their phone or any kind of really lightweight device. And we've had people running light nodes on phones, on Nintendo Switches, on lots and lots of different pieces of hardware, like Kindles and everything, just to show that now with modular blockchains, it's actually possible for anyone in the world, practically, to verify the chain directly. And this is a huge boon for decentralization of blockchain networks, because end users verifying the chain are what secure blockchains. And so here's an image of one of our team members, Josh, running a light node on his phone just a few months ago in Paris. And last thing, it's more touching on like the social aspect of modular, the modular movement, which is that in the monolithic world and the monolithic framework, you have these isolated L1s that are not sharing resources, not sharing innovation. They're pitted against each other in sort of a zero-sum competition for adoption and mindshare. And in the modular approach, you split this up and you enable different chains and different projects to collaborate and share innovation. And so it becomes a much more positive sum ecosystem that can innovate much faster. And so I'm really excited about this aspect of modular blockchains, aside from just the technology, the social aspect of, and we call this modularism, not maximalism. And the modular ecosystem has been growing significantly. Just in the past year, it's almost tripled in size, and there's tons of new, it's not just that there's more projects building the same things, there are actually new layers that have emerged to kind of service other aspects of building blockchains in a decentralized modular way. And I expect this trend to continue where more and more of the blockchain stack overall modularizes and more teams join into this movement. So it's a really exciting time. And last but not least, Celestia is very close to launching our mainnet. And this is going to be a huge shift in the sort of like history of blockchains, in that for the first time we'll have a network that has live data availability sampling, and we'll be able to scale decentralized block space for rollups and for applications. But I have this slide here because mainnet launch is really just the first step for Celestia. And once we launch, we have another goalpost that we've set for ourselves down in the coming years. And that is this. We want to get to a place where we have 1 gigabyte blocks, 1 million rollups, and 1 billion light nodes. So what this means is for the 1 gigabyte blocks, this is about scaling the underlying block space so that we can actually support global usage of blockchain and crypto. And we think it's possible using data availability sampling to have to scale to this size. And the second point about 1 million rollups is that we want to make it as easy to deploy a rollup as it is to deploy a smart contract. And we want to enable, in the same way that Ethereum enabled all this innovation and experimentation at the smart contract layer, we want to enable experimentation and innovation at the roll-up execution layer. And we think that this is going to unlock, again, another wave of new types of applications that could not exist before. And so hopefully by having this bloom of 1 million rollups, we'll get there. And then the last point is 1 billion light nodes. And what this refers to is that part of what scales these blockchains and also what makes them decentralized, as I said, is users verifying the chain. And so we need to build a system where we can have end users verifying Celestia and running nodes at scale. And we believe that we can do this by embedding light nodes into wallets and into browsers and making it sort of a cultural aspect of the modular ecosystem. And that's all I have today. So hopefully you're inspired by the modular movement and you guys want to build or participate. And you can find me on Twitter. And our website is celestia.org. And stay tuned for the next couple months for our mainnet launch. So thank you so much.